This is a lecture video for section 6.4, video 2. Here we're going to talking about one trigonometry equation involving inverse function. So example 3 we want to solve the arc cosine of x minus arc sine x equals to pi. So we have inverse function here. So how I'm going to starting it is I'm going to start by rewriting the equation arc cosine of x minus arc sine of x equals to pi into adding arc sine of x on both sides. The reason for it is in the futures, if I want to do anything, it's easier to deal with equation has one trig values on one side of equation and the other on the other side of equations. And then using the definition of inverse function, I can rewrite arc sine of x as an angle theta. And from it, I can see that sine of theta will equal to x. Continue from that point, I can draw a right triangle with angle theta. Sine of theta equal to x, or x over 1, tells me I have the following measures for two of the leg, and then the third one I can using the Pythagorean theorem to find it. So in this right triangle, I have hypotenuse equal to 1. One of the leg equals to x, the other leg is square root of 1 minus x squared. Okay, so go back to my mean steps. I'm going to rewrite my arc sine of x as a theta. Then I have arc cosine of x equals to pi plus theta. Using the inverse function definition, I can write as cosine of pi plus theta equals to x. Now I see a sum formula for the cosine, sum of angles for the cosine. So cosine of a plus b equals to cosine of a cosine of b minus sine of a sine of b. So I'm going to use that formula to expanding the cosine of pi plus theta. So I got cosine of pi times cosine of theta minus sine of pi times sine of theta equals to x, where cosine of pi will equals to -1 and sine of pi will equals to 0. So I end up with negative cosine of theta equals to x. Okay, so remember we're talking about the right triangles here on the left. So cosine of theta, or cosine of theta equals to -x. Cosine of theta, I can also find it through this right triangle. Cosine of theta is square root of 1 minus x squared over 1. So plugging that one in, I will have square root of 1 minus x squared equal to -x. Now I need to solve this radical equation, squaring both sides of the equation. And I will have 1 minus x squared equals to x squared. Solving it, 1 equals to 2x squared, x squared equals to 1/2, and x equals to positive or negative square root 2 over 2. So we have two answers, but we're not sure which one is the correct one. Okay, so go back. So if x equals to positive square root 2 over 2, then what we have, which I'm talking about this equation here. then what I will have is cosine of theta equals to negative x, which is negative square root 2 over 2. If x equals to negative square root 2 over 2, then cosine of theta equal to negative x will equal to positive square root 2 over 2. How do I know which answer is the correct one? Then I need to go back to my domain and range definition for the inverse function. We have two inverse functions. The first one, by the definition, I said arc sine of x equals to theta. The inverse function, that tells me theta is going to be in between pi over 2 to pi over 2. We also have another piece, have an inverse function, which is the arc cosine x equals to pi plus theta. So arc cosine of x equals to pi plus theta. That tells me the angle pi plus theta together is going to be between 0 to pi, quadrant 1 and quadrant 2. Then from this equation, I can solve for theta by subtracting pi on both sides. So I will end up with theta is going to be between negative pi to 0. Combining both inequality, what I know is they are overlapping from negative pi over 2 to 0. So this is the range, or this is where my theta has to be lies in quadrant 4 in order to making sure both of my inverse function arc sine and arc cosine follow their proper range for the restriction. From that discussion, we know theta is in quadrant 4. In quadrant 4, cosine of theta in quadrant 4 is going to be positive. The only situations I will have a positive one is when x equals to negative square root 2 over 2, where cosine of theta equal to negative x, which is positive square root 2 over 2. So the final answer, x is going to equal to negative square root 2 over 2. Okay, so this is a really comprehensive example. We use the right triangle Pythagorean identity to figure out all the cosine theta, sine theta, maybe in the future if we need tangent theta or anything else. We also use the identities, which for this case we're using the sum of two cosine angle identities to breaking inverse function. And then we also use the range for inverse function to figure out what is my answer is going to be for theta. And then basing on the theta, we're going to determine what is the sign for my cosine theta, and then to determine what is my proper x value.